Let's do this problem. Find the voltage across the 4 ohm resistor in the network, right? So 4 ohm resistor means this is the resistor. So one particularity about this problem is that this has a dependent source. Okay, so I just want you to get familiarized with how the dependent source comes. So if the dependent source comes to the picture, there's nothing unusual about it. Just simply do the problem as you did before. Only thing is that just find the equation of the dependent source. That's all. See here, this is the dependent source, right? Here this is a dependent voltage source and the value of this voltage source is 2ix. 2ix means it's a current, right? Current value. So that means this is a voltage source which is controlled by the current called ix. And what is ix? Ix is the current through this branch. Current that is flowing through this 2 ohm resistor, right? So this is a current controlled voltage source, right? Current controlled voltage source. This is a dependent voltage source, okay? So now let's mark the mesh currents I1 and this is I2. Okay, so here saying find the voltage across a 4 ohm resistor, which means we need to first find the current across the 4 ohm resistor, and the current across the 4 ohm resistor is I2, right? So which means the voltage across the 4 ohm resistor is 4 into I2. That's the voltage across the 4 ohm resistor. Now and what is the value of ix? So now first you need to define the equation of ix, right? So ix is the current through this branch, and according to your mesh current, the current through this branch is also I1, which is, so therefore the equation for the source is ix is equal to I1. Therefore, the equation of this dependent source. So that's the only difference. It is first when you see a dependent source anywhere in the problem, first you find the equation for the dependent source. Right? You find the equation of the dependent source. So here the variable is ix. So you need to find the equation of ix. So depending on what is ix, you write the corresponding equation of ix. So here ix is in this branch, therefore in the same branch the current is also I1, which is therefore ix is equal to I1, right? That's all. Now you can do this problem like as if assuming that this is a normal voltage source. That's all. Okay. So equation for mesh 1. Equation for mesh 1, which means I1 is considered as positive and I2 is considered as negative, right? So I1 is touching this 2 ohm and this minus j, right? There's no other impedance over here, only this 2 and this minus j. So it is 2 minus j, okay, minus I2 into, and I2 is touching only this, right? So I2 is touching only this, so it is minus j. It's a capacitor, that's why it's minus j, okay? And this is equal to, and there are two voltage, so that is this 6 angle 30 and this 2ix, right? And if you look at over here, this I1 is coming out of the positive terminal, which means this positive terminal is generating I1, right? So this is plus 6 angle 30, 6 angle 30. And what about this voltage source? This I1 is flowing into this positive terminal of 2ix. It's flowing into the positive terminal, which means this positive terminal is not generating I1, it is opposing I1. Therefore, it is minus 2ix. This is the equation of mesh 1. Okay. Now what I can do is I can simplify this equation, right? Because I already know that ix is equal to I1. So I can substitute that over here and bring that thing over here. So this little equation becomes more simple, which means I1 into 2 minus j minus, and here minus is plus, so no need to write minus again, plus I2 into j, okay, is equal to, what is 6 angle 30? Let me see. 6 angle 30 is 6 shift angle 30 is equal to 3 root 3 plus 3j. 3 root 3 plus 3j minus, and what is ix? We already know that ix is I1, so minus 2i1, which means I can bring this term over here, right? So if I bring this term over here, this will become I1 into, this becomes plus 2i1. So 2 plus 2 becomes 4. This is 4 minus j plus I2 into j is equal to 3 root 3 plus 3j. Okay, so this comes over here. This is the equation for mesh 1. Alright, now equation for mesh 2. Equation for mesh 2, so which means here I1 is considered as negative and I2 is considered as positive. So minus I1 into, and I1 is touching only this impedance, right? What is this? Minus J. So minus J plus I2 into, and what is I2 is touching? This minus J, this plus 2J, and this 4 ohm, which is 4 plus 2J minus J, which is 4 plus J, right? So this is 4 plus J is equal to, and what about the voltage source? Only this voltage source over here, and in this voltage source, this I2 is coming out of this positive terminal, right? It is coming out of this positive terminal, which means this positive terminal is generating I2, which means 2ix is positive. 2ix is positive, right? But we already know that ix is I1, therefore I can write this as I1 into J. Minus or minus is plus, right? So it's I1 into J plus I2 into 4 plus J is equal to 2I1. And if I bring this term over here, this will become I1 into, this term over here becomes minus 2I1. So it becomes minus 2 plus J plus I2 into 4 plus J is equal to 0. So now I can write this in matrix format. So which means the coefficient of I1 over here is 4 minus J. The coefficient of I2 is J. The coefficient I1 over here is minus 2 plus J. The coefficient of I2 is 4 plus J. Okay, the variables are I1 and I2. And the constants are 3 root 3 plus 3J. 3 root 3 plus 3J and 0. Right, this is it. But here they ask find the voltage across a 4 ohm resistor, which means the current across a 4 ohm resistor is I2. So simply find the value of I2. So what is I2? I2 is equal to, the numerator determinant will become I2, right? So this is 4 minus J minus 2 plus J, and the second column is replaced with this 3 root 3 plus 3J into 0 divided by, and the denominator it will be this coefficient matrix 4 minus J minus 2 plus J, J and 4 plus J, right? So which means, let me see, therefore I2 is equal to 4 minus J into 0 is 0 itself, and minus of this, so therefore we will have minus of minus 2 plus J into 3 root 3 plus 3J. 3 root 3 plus 3J. This is the numerator, and the denominator, it is 4 minus J into 4 plus J. 4 minus J into 4 plus J. Then we have minus of minus 2 plus J into J. Minus 2 plus J into J. This is the equation. So let me first find the, here if I put minus inside this will become 2 minus J, right? I can simplify this. This is 2 minus J into 3 root 3 plus 3J, right? And what about the denominator? Also the same thing over here, right? So this will become 4 minus J into 4 plus J. Let me see. 4 minus J into 4 plus J. 4 minus J into 4 plus J is equal to 17. This is equal to 17. So this is 17 plus this is J into, J into 2 minus J. I can write like that, right? J into 2 minus J. I can write like this. So this is it. So what's the numerator value? The value of numerator is 2 minus J, and this is 3 root 3 plus 3J, and you will get, let me write like this, 13.3923 plus 0.8038 8038J by, and what about the denominator? Just 17 plus 17 plus j into 2 minus j. 17 plus j into 2 minus j. 17 plus j into 2 minus j, we will get 18 plus 2j. 18 plus 2j. So this is 18 plus 2j. Therefore, what is the value of I2? Therefore, the value of I2 is 13.3923 plus 0.8038 j divided by 18 plus 2j. 8038j plus 13.3923. You will get 0.7398. 0.7398 minus 0.0375j. Okay, minus 0.0375j. Right, this is the answer. But so which means the voltage across the 4 ohm resistor is equal to I into R. R is 4, right? So 4 into I2, 4I2, which means 4 into this value, 0.7398 minus 0.0375j, which is equal to, this answer into 4, right? This answer into 4, and you will get 2.9594. 2.9594 minus 0.1502. 0.1502j. Okay, this or its polar form, it will be written as 2.9632. 2.9632 angle is minus 2.9054. minus 2.9054 degree volt. This is the voltage across the 4 ohm resistor. Okay.